Yeah, so we are looking at the concept of acids, bases, and salts. We have the Arrhenius concept, the Bronsted-Lowry concept, and the Lewis concept. So let's start with the Arrhenius concept. Arrhenius concept is about putting a substance or a compound in water. If that substance or compound produces H plus ions or H3O plus ions, then it is an acid. But if it produces OH minus ions, then it is a base. So H plus, you can call it hydrogen ions, yeah, hydrogen ion or a proton. Then H3O plus is hydrozonium ion. Then OH minus is hydroxyl ion or hydroxide ion. Yeah, so that is Arrhenius concept of acids and bases. So let's say we have HCl aqueous, meaning what it's in a water is in there. So it's going to ionize to give us H plus and Cl minus. So which this means that HCl is an acid. According to Arrhenius, if you put a compound in a water or in an aqueous medium or in aqueous solution and produces H plus ions, then it is an acid. We could have done it this way to give us H3O plus plus Cl minus. Yeah. So this thing here is H plus and Cl minus coming together. So this plus is going here. So it becomes three hydrogens and the plus over there. That's it. It came with a plus, leaving the Cl minus here. So that is Arrhenius concept. Let's say we have sodium hydroxide in aqueous medium. It's going to give us Na plus plus OH minus. The OH minus will tell us that okay, sodium hydroxide is a base. We're having calcium hydroxide aqueous. This will give us Ca2 plus plus OH minus. The OH minus is saying us that okay, calcium hydroxide is a base. That is the Arrhenius concept. Now move on to Bronsted and Lowry. So Bronsted-Lowry concept. They are saying that if you're an acid, you donate H plus. If you're a base, you accept H plus. So H plus, we said, is a, you can call it a proton. So an acid is a proton donor. A base is a proton acceptor. That is Bronsted-Lowry concept. So let's take CH3 COOH. This is an alkanoic acid. So this is methanoic acid, RCOOH. Alkanoic acid. You saw it in organic this semester. Yeah, so this is methanoic acid. Sorry, ethanoic acid. We are seeing two carbons there. So 2 is 8. Ethanoic acid. Yeah, so let's put it in water. H2O. What is going to happen here? This ethanoic acid can donate this H plus to this. So we are seeing this as CH3 COO minus and then H plus. So when the H plus goes here, it becomes H3O plus, leaving CH3 COO minus. Alright, so because this was able to donate H plus, a proton, to this, then this is what? Bronsted-Lowry acid. So Bl acid. Bronsted-Lowry acid. And because the water was able to accept the H plus from the Bronsted-Lowry acid, it becomes what? The Bronsted-Lowry base. Then we have something called conjugate pairs. Now, look at this Bronsted-Lowry acid. After it has donated the H plus, it formed this ion. Now, this thing here is what's going to be the conjugate. Since this is an acid, since here is an acid, then the ion it will form after donating will be a conjugate base. Yeah, it will be a conjugate base because it can also accept a proton back to form this. Assuming you give H plus, we have CH3, COO minus, and you give H plus weight to accept that proton to form this. So it's a base. A base is a proton acceptor. Alright, this is our Bronsted-Lowry base. After it has accepted the proton from the acid, it will form what? The conjugate acid, meaning that it can also donate a proton back to somebody and form the water back. Yeah. So what are conjugate pairs? Conjugate pairs. So they are what? A pair of species that differ by a proton. A proton is H plus. You can see this and this. The difference between them is just what? Hydrogen, H plus. You can see this one too and that one. The difference between them is just what? Hydrogen, H plus. So they are conjugate pairs. Now, one thing about conjugate pairs, if one is weak, the other is what? Strong, and vice versa. If one is weak, the other is strong, and vice versa. So ethanoic acid is a weak acid, so its conjugate base will be a strong base, and vice versa. So that is Bronsted and Lowry concept. Now we move on to what? Lewis concept. Lewis concept of acids, bases, and salts. So what is Lewis saying? Okay, so if you are an acid, you have empty orbitals to accept electron pair. So electron pair acceptor. And if you are a base, you have what? Lone pair electrons. And then you'll be able to donate. So electron pair donor. That is what Lewis concept is saying. So we know that positive ions are having empty orbitals. Positive means that they are lacking electrons, they are deficient in electrons. Yes, so if I give you something like Cu2 plus, this is a positive ion. The positive sign should tell you that it's deficient in electrons, so it has empty orbitals to accommodate electrons. So this can act as a Lewis acid. If I give you water, H2O, you know that water has lone pair. Dial 321 and make a phone call. Fluorine has 3 lone pairs, oxygen has 2 lone pairs, nitrogen has 2 lone pairs. So water is like this. And we know the shape of water is bent or V shape. Yeah. So oxygen has 2 lone pairs. I can see 2 lone pairs of electron here. Let me draw ammonia. You can see that okay, it has 1 lone pair. The nitrogen there has 1 lone pair. So this will be what? Lewis bases. So ammonia, water, and the negative species, negative ions, they are what? Lewis bases. We know this. And also from hybridization, BX3 compounds, BEX2 compounds. So BX3, aluminum 2 here, ALX3, and BEX2 compounds. They also form Lewis acids plus the positive ions. So if I give you aluminum chloride, it will be a Lewis acid. Yeah, then the bases. So these guys, those with lone pairs, species with lone pairs will form what? Lewis bases. And negative ions, please don't forget negative ions, they form the Lewis bases. And compounds with lone pairs, if I give you Cl minus, to form a Lewis base. Alright, also you should take note that all Bronsted-Lowry acids and bases are also Lewis bases. So let me stress something on the Bronsted-Lowry acid and the Bronsted-Lowry base. Now we said that according to Bronsted and Lowry, we said an acid is a proton donor. So before you can qualify to be a Bronsted-Lowry acid, you should have hydrogens, or you should have what? Protons in you before you can donate. If not, then you can't form what? You can't be a Bronsted-Lowry acid. And if you are a Bronsted-Lowry base, you should have some lone pair of electrons there, so that you can accept that proton, because that proton coming is positive. It's positively charged, meaning it has empty orbitals. So you should have lone pair of electrons to give it, so that you'll be able to form a bond, equivalent bond. So this is the concept of the three concepts you'll be meeting: Arrhenius, Bronsted and Lowry, and then the Lewis concept.